Alright everyone, now we have a question under the topic of probability distribution. We have a first part here. It's asking you, okay, we'll read the question first. Now a bag contains 5 red balls and 3 blue balls. Sadi takes 3 balls at random from the bag without replacement. Without replacement is our key point here, okay? Now the random variable x represents the number of red balls that she takes. Let's take this down. Now you have red, total of 5 balls, blue, total of 3 balls, and then the process here, you need to know the process takes 3 ball without replacement. That's your key point, okay? R/B, okay, replacement. Now let's move on. It says x, so x represents number of red balls. Okay, part A, we want to show the probability that Sadi takes exactly 1 red ball is 15 over 56. Okay, now you have to be careful with this. Exactly 1 red ball does not mean red, blue, blue. Okay, we have to make sure we take note of all possible sequences of these red ball. So if we list down, we can have red. Let's say our first choice is red, which means the rest has to be blue and blue. Next is our red is going to be in the middle. Now lastly, our red is going to be at the last one. Okay, so first one, if we take the red ball first, we are going to have a probability of 5 over 8. Now we're taking blue next. That's going to be 3 over 7. So take note that it becomes 7 because of without replacement. Now we're taking blue again. That's going to be 2 over 6. Then when we calculate this, it's going to give us 5 over 56. Next sequence, we have blue first. So blue is going to be 3 over 8 times red is going to be 5 over 7. Then blue is going to give you 2 over 6. Okay, and this will also give us 5 over 56. Now the last part, we have blue first. So blue is going to give us 5 over 8, then times 4 over 7. Then finally we have 5. Oh, sorry, blue, right? Not red. So blue is going to be 3 over 8 times 2 over 7 times 5 over 6. And this will also give us 5 over 56. Now, since we've listed out all the possible events of getting exactly 1 red, we have each of these different events. So we want to add all of these events. So we're going to plus them all, and we will get the answer of when probability of x is equals to 1, it is equals to 15 over 56. Okay, now let's move on to part B. So part B, we want to draw up the probability distribution for table X. So probability distribution, let's list out the possible outcomes of X. We have no red, we have 1 red, we have 2 reds, and finally we have 3 reds. Okay, so now let's find the probability of each, right? Probability of X equals to X. Now finding 0. So 0, probability of x is equals to 0 is going to be all blue, right? So blue, blue, blue. So getting all blues is going to be 3 over 8 times 2 over 7 times 1 over 6. And that is going to be 3 over 8 times 2 over 7 times 1 over 6. And that's going to give you 1 over 56. And then for 1, we already found it, which is 15 over 56. And then for 2, when x is equal to 2, the possibilities are red, red, blue, and then red, blue, red, and then also blue, blue, red, red. Okay, now you notice that all these three is actually the same. Now as long as it has the same amount of red and same amount of blue. That's the same case with this. When x is equals to 2, you always have the same amount of red and the same amount of blue. and each of these is going to give you the same outcome. So as a shortcut, let's just focus on one, and in the end, since we know there's 3 possible outcomes, we'll just multiply it by 3. Now getting a red will be 5/8 times next red is 4/7, then blue we get 3/6. Okay, and then we get 5/28. Now let's multiply this by 3 because there are 3 possible outcomes, and we should get 15/28. So 15/28. Now for probability of x is equals to 3, that's going to be equals to red, which means it's just 5/8 times 4/7 times 3/6. Okay, now that's exactly going to be the same as the 5/28. It's just 1 saja. Okay, you can see that's exactly the same. Now moving on to the last part, we have part C. We want to find variance, and the expectation has been given to us, which is equals to 15/8. Okay, now for formula of variance, we need to remember that it's going to be e of x square minus bracket e of x square. Okay, so now finding the probability of e of x is going to be the sum of x squared p minus bracket the sum of xp, the whole thing squared. Okay, now I'm going to skip some steps and I'm just going to write down the sum of x squared p. Right, so I found out that e of x squared is going to be equals to 225/56, while the mean square is 225/64. Then when we subtract them, we get 0.502, or in this case 225/448. Okay.